طيب today we will start a new chapter هو tutorial 6 linear transformation and the null space and the range. طيب we knew in our previous classes what do we mean by the vector space, correct? طيب now before we had functions, correct? In other courses in our secondary schools, and for instance, if I have here this set and we call it the domain, okay, the domain, and this is the codomain, so we can define a function, okay, there is a function that maps the element of this set A to this set B. Yes, يعني مثلا if this is X and this is Y and this is F, so F acting on X, so F of X, we say that it is equal Y, and we say that Y is the image of X, correct? Yes, the first set is the domain and the second set is the codomain. Okay, now we will define, instead we call it a function, we are going to define the linear transformation. And this linear transformation, it will map an element in a vector space V to another vector space. Let's call it W. Okay, so this هنا عبارة عن شنو؟ Vectors. They are vectors. X1, X2, X3, and etc. Okay, so for instance, this is X1. So this transformation will act on this and will map it to شنو؟ To a certain vector here in W. Okay, so we can call it T of X because this is the transformation T. Okay, so T when act of X, this one we will call it T of X. If you want to call it Y, then it's okay. Okay, but this is the image, correct, of the vector X when it acts upon by by the linear transformation X. Clear? So we say T of X, T when act of X بتديني شنو؟ T of X and etc. On X2 then T of X2 etc. Clear? طيب هل any mapping we call it a linear transformation or it should satisfy certain conditions? طيب not any map. The map we call it linear transformation if two conditions are satisfied. What are these conditions? What are these conditions? Type. The first condition is that, okay, if we have a vector, يعني طبعا ده عبارة عن set of vectors. If this is V, we have set of vectors. For instance, let's say we are taking the first vector X and another vector here Y. And then since this is a vector space, we should also have here the vector what? X plus Y, correct? دي من شروط الفيكتور space. Not only this, also we should find here what? C of X. We should find C of Y. That is a constant multiplied by X and a constant multiplied by Y, correct? So for instance, we can have C of X and etc. So for every two vectors here, okay, the addition of them is also here because this is a vector space. And for each vector like X, C of X also it is here where C is a constant and etc. Type. And in the other set, what do we have? The same because it's a vector space and it is W. Correct? So for instance, if we have here T of X, any element, let's call it T of X. Okay, or else if you want to, let me now name it like QV. Okay. Type. Okay, so if we have this is U, okay, vector u, okay, and then we have another vector, let's call it v. لا u v أنا مستعملاهم كمان no, let's call them n and m مثلا. Okay, so this is n and this is m. Okay, so since this is also a vector space, we should find what here? N, a vector, which is the addition of n plus m, another vector, correct? And as well, we should find, for instance, some constant, let's call it k, phi n, and etc. طيب, the transformation, we call it a linear transformation. If what happens? لو كان a transformation of x is n and the transformation of y, for instance, is m, okay, then the transformation of xy should be what? Transformation of xy should be the transformation of x plus the transformation of y. That is, transformation of x was n or transformation of y was m. يبقى المفروض يكون n plus m. Transformation of xy should be what? n plus m. You got it? So the first thing is that if a transformation of x is this one, okay, so this is t of x, we call it t of x. ال n هي عبارة عن شنو؟ ال n هي عبارة عن ال image of x, so we call it t of x. Okay, and the m is what? Is t of y. Yes, then what? The transformation of x plus y, okay, so it should be n plus m. Okay, so this is what اللي هي هيكون يبقى this one, transformation of x plus y, it should be equal to that. So the transformation of the vector x plus y should equal to n plus m, which is the transformation of x plus the transformation of y. Is it clear? Okay, so if this is n is the transformation of this and the transformation is y is m, then the transformation of their addition of this vector, it should be the sum of these two, which is m plus m, and it should be there in this, because in this set, because this is a vector space, so that should be mapped to this type. This is the first condition. What is the second condition? The same. If we have, this is the vector v and this is the vector w, okay, and if we have here the vector x, then we should have the vector what? Cx, correct? Type. If the transformation of x is an element here, okay, let's call it n. Type. Since n is here, we should have what? Any constant times n. Let's call it kn. Okay, so what will happen? Okay, we should have, we should have cn, okay, any constant, any real number. So one of these is, one of the vectors, when you multiply by one of the vectors, is the multiplication of n by c. يعني c1 n is there, c2 n is there, since here there is a C, another real number Cn is also there. So no matter what is C, الvalue بتاعت C for every real number. Why? Because this is a vector space we said from the beginning. طيب, now if n is the image of x, that is t when act of x, it will give me n. يعني we have what? n هي الإيمج حقت الx, t of x. Okay. If the transformation is linear, then the transformation of cx should equal what? Should equal to this. يعني this one should be mapped to that one. So what? That is the transformation of cx. It should equal to c في transformation of x. What is the transformation of x? Isn't it the n? Yeah, it is the n. So n times c, so that is cn. طيب, اللي بيساوي, what is the transformation of this one? cn as well. Is it clear? يبقى two conditions should be satisfied if this is a linear transformation from the vector space V to the vector space W. That is the transformation of the addition. The transformation of the addition should equal to the transformation of x, which is n, plus the transformation of y. صح? What is the transformation of x plus y? We found it that n plus m. It's the same as this plus that. Transform, because this is m plus m, n, correct? يبقى the transformation of x plus y should equal the transformation of x plus the transformation of y. As if you what distribute the t, but it's not the case. ما صح, بس عشان تحفظها. Transformation of the addition is equal the transformation of the first vector plus the transformation of the second vector. Moreover, the transformation of the vector, the new vector, that you get it by multiplying c by x, okay? So the transformation is the same as the transformation of x, and then you multiply by the c. You got it? Okay. Now, here there is an example. Take the transformation from R2 to R2. How it is defined, this transformation? He said every element xy will be mapped to what? We flipped محل x, y, and in the place of the y, then it is x. This is how this map is defined, or how this transformation is defined. Let me show you. طيب, for instance, مثلا take any, لأنه from R2, so R2, any vector في R2. For instance, take the vector 1, 2. As per this transformation, it will map this element 1, 2 to what? 2. We flip, correct? 2, 1, and etc. Correct? مثلا, if I have -5 or 7 in the first, what? This is the first, اللي هو R2. The element in R2, and this is as well element in R2. Okay, because from R2 to R2. Okay, بدل الU والV. Okay, so what is this will be mapped to what? 7 and -5 and etc. So is it clear how the map work? Okay, now we want to prove that this transformation is a linear transformation. That means the two conditions should be satisfied. How we prove that? This is quite easy. I'll show you how. Type. What we'll do? First, we will take two elements from the first set. We call the first one x and the second one y. Okay, so let what? Let x1, okay, x or x is the vector. Let's call it then مثلا x1 y1. Capital X. Okay. If you want to call it u, it's up to you. بدل ما هنا مستعملين x وهير x. Okay. So let's call لكن that is the vector space. Okay, big X. Okay. And this is big Y. Is the vector, the other vector, which is x2, y2, for instance. Okay. Now what we need the vector x plus the vector y. So what is this? This is equal to addition of this one and that one, correct? So it is how we add each element to the corresponding one, correct? So here the first element is going to be x1 plus x2. And the second one should going to be y1 plus y2. يبقى at the beginning what we say, let x or y belong to element from where? From the vector space R2. يبقى since they belong to R2, they look like that. The first vector is like this and the second vector is like that. Now, what's their addition? This is their addition. What we want to prove? We want to prove first this one here, that the transformation of the addition is going to be equal to this one too. Type. Now, what is the transformation of x? What is the transformation of x? The vector, the big X. How it work? We do what? We flip, correct? Type. So it's going to be equal to y1, x1. Correct? Type. What is the transformation of y? Also, we flip the other one. So it is y2, y or x1 or x2. Yes? Okay. Now, what we want to find? We want to test, is this one going to be equal this one plus this one or no? Is it going to be equal to this plus this or no? Type. Okay. So let's find a transformation of what? The vector x plus y. Type. What is the x plus y? It is this vector. So what do we need? We need the transformation of this vector اللي هو x1 plus x2 و y1 here, the other element, plus y2. طيب, what is the transformation of this? What we do? How it is defined? We flip, correct? طيب, so this is equal to y1 plus y2 و x1 plus x2, correct? طيب, but this we can write it as what? We can write it as y1 or x1, correct? Plus y2 x2, correct? This is equal to this. Yes. Type, but what is this? Isn't it this? Isn't it the transformation of x? Yes. So this is equal to the transformation of x plus what? What is that? It is this part, correct? Yes, يبقى plus the transformation of the vector y. So what we did, we proved this is correct for this kind of transformations, correct? Transformation of x plus y, we started from this and we ended up that this one is equal to the transformation of the x alone plus the transformation of y. يبقى we proved the first condition. What remains to prove the other? Does it work or no? Yes? طيب. Now what we need? What is c of x? What is the vector c of x? احنا عايزين نثبت الثاني. اوكي؟ خلصنا الأول. طيب what is c of x? It's the vector c في x1 و c في x2. Okay, دي بكابيتال X ها. Okay, so it is like that. طيب يبقى what we need? We need to find the transformation of this. So the transformation of this should equal to the transformation of this. Okay. طيب what is the transformation of this? How it works? We knew that. Just we flip. So it is c x2 وهنا c sorry هنا هو دي x1 x1 y1 أنا التسميات معلش. This should be y1. Okay, so it is c. How is y1? طيب c y1 وهنا c x1. طيب دي a vector. It is multiplied by a constant, all the column, correct? So we can take the c out. So this vector is equal to c multiplied by the vector, what? y1, x1. But what is this vector? It is correct. So if this is equal to c of the transformation of what? Of x1, y1, which is equal to c. احنا عايزين نوصل لشنو؟ c transformation of the x, the vector x. يبقى the transformation of the vector cx, it's the same as the transformation of the vector x, and then the answer we multiplied by the constant c. يبقى yes, since these two conditions are satisfied, يبقى this transformation is what? Linear transformation. Clear? Is it clear? When we do some other examples, it will be more clear. طيب. Now, instead of doing these two operations alone, we can join them and prove in one step. بدل ما نجيب transformation حق الاديشن and then the transformation of a scalar multiplication, okay, we can do them both in one step. يعني we can prove, if we want to prove that this is a linear transformation, we can prove transformation of a constant times the vector x plus y is equal to constant times the transformation of x plus transformation of y. So we do two in one step. If you want to do like that, it's also correct. But if you want to do them to test the two conditions in one step, so you go like that. طيب. يبقى the mapping T from the vector space V to the vector space W is a linear transformation if T of Cx plus Y is equal to C, T of X plus T of Y for every XY in the vector space V. And طبعا for every C real number. Okay. يعني I'm not going to take here لما ناخد XY because I took them arbitrary. So that means it is, you know, for every vector here, this and vector here, this relation will work. Okay, clear? طيب. Then From that, we will get if T is a linear transformation, if it is a linear transformation, two things will happen. Transformation of the zero vector, okay, should equal to a zero. And if we have this is our vector space V, and this is our vector space W, okay, if this is the zero vector here, then the map of this zero vector should be to the zero vector here. يعني T, when act on this, it should give me that. This is one. So if this is a linear transformation, that means you are sure, as per this theorem, that the transformation of this should be that. And if this doesn't happen, then immediately that this is not a linear transformation. Clear? And the second thing, that the transformation of a constant times x plus a constant times y should equal to the same as, this constant times the transformation of x plus this constant times the transformation of y. So this should equal to that. Clear? يبقى if I want to test that this is a linear transformation or no, we can test. لا, to prove that, yeah, it is a linear transformation or no, just test this. If it is not working, then that means it is not a linear transformation. طيب, if it works, does that mean it is a linear transformation? No. ليه؟ لأنه there is another condition that should be satisfied. يبقى ده easily I can check with it from the beginning هو linear transformation or no. If this doesn't satisfy, يبقى immediately هقول شنو? It is not a linear transformation. But if it is satisfied, can I say that it is linear transformation? No. Why? To be a linear transformation, this should happen. But as well, this should happen. Clear? Let's see some examples here. Show that the mapping T from R3 to R2. يبقى vector space we knew before R3 with the normal addition our standard addition and scalar multiplication, it's a vector space. And this as well is a vector space, correct? Yeah. Type. Now he wants us to show that this mapping, which is defined like that, it is what? It is a linear transformation. First, I have to understand how the map works. Type how the map works. This is really, yeah, it was from R3. And as well, this was from R2. Okay, so from R3 to R2, the map is taking me from here to here. Okay. How it works? The first element here should be the same as this one here. And the second element is the addition of these two, correct? If we knew how the transformation is working. Now we want to prove that it is a linear transformation. What we do? We have to prove these two conditions or use this one. وخلاص, I'm done. طيب. If we want to prove the two conditions, first I have to take from the first, from this one, two vectors. You can call them X, Y, you can, whatever. Okay, so take two vectors here and then add them. يبقى هقول شنو؟ Let مثلا capital X and capital Y, where? I'll take them from where? From R3. Belong to R3. So what is your X looks like? You can write X1, Y1, Z1, for instance, like he did here. So this is the vector X. What is the vector Y? Another vector, but from R3, also 3 elements should be there. Let's call it X2, Y2, Z2. يبقى I took 2 from here. Now الstatement بتاع theorem شنو? Okay, if you took any 2 vectors from here, then the transformation of x plus y should equal to the transformation of the first alone plus the transformation of the second. Correct? This is the statement, the first statement of the theorem, of the first condition. So now what I do, I have to get this. So that means what? I have to add this one to that one. Correct? يبقى هيكون عندي we want transformation of what? Of the first vector, which is x1, y1, z1. We add to it x2, y2, z2, correct? And after the addition, we find the transformation. Okay, so this is equal to what? This is equal to transformation of, now we add, how we add? Each element to the corresponding, correct? So this is x1 plus x2. And this is y1 plus y2. And this one z1 plus z2. And now after we made the addition, what we do? Now we find the transformation of this vector اللي هو third vector اللي هو عبارة عن ال x plus the y. So what is the transformation? Now we come back. How it works? The first element is the same as this one. So what is the resultant? The resultant is equal to الفيرست هو هيكون شنو؟ x1 plus x2 as it is. But what about the second element? The second element is the addition of this and this, correct? So it is y1 plus y2 plus z1 plus z2. Okay, where I want to reach? I want to separate them, correct? Because I need this alone and for the y alone, correct? يعني I need الحاجات اللي فيها x1 y1 و z1 alone واللي فيها x2 y2 و z2 alone. Can I do it? If this is my case, yes, I can easily do. Okay, what do we have? This is the x1 and this is the y1 and this is the z1, correct? So this is equal to, this vector here is equal to what? x1 y1 plus z1, the first vector, plus the second vector, which is x2 y2 plus z2. Yes, this and these are equal. Okay, because I'm looking where I want to reach. But what is this? What is this? It is the transformation of this vector, correct? If we get this one is the transformation of the first vector, correct? اللي هو شنو؟ x1 y1 و z1 plus what is this? This is the transformation of the other vector, which is x2 y2 and z2, correct? Okay, so this is the transformation of the vector x plus the transformation, because from the beginning we call it x, transformation of the vector y. يبقى I'm done, yeah, with this. I prove that the transformation of x plus the transformation of x plus y is equal to the transformation of x plus the transformation of y. I started from here and I ended that this is equal to this. So I'm done with the first condition. Clear? طيب. يبقى I'm done with the second, with the first. Now we do what? We want to find the second one. What do we want to prove? We want to prove that the transformation, الحاجة الثانية, we want to prove that a transformation of the vector cx should equal to c في transformation of x. Okay, يعني before after we multiply we get the transformation. It is the same as this transformation حق x, and then after we multiply by the c. How? Here y1 plus z1. This is y1 plus z1. It is what? It is x1. This vector became to this step here or before. افتح المايك. كيف من هنا نحن جبنا هنا؟ ليه؟ لانه transformation defined كيف؟ الفيكتور ده هو عباره عن شنو؟ ده هو عباره عن الترانسفورميشن بتاع x y و z. ده الديفينيشن اللي اداني له هو للترانسفورميشن. He said we map from R3 to R2. We go from R3 to R2. How we go? يعني مثلا if we have okay, we have here element, how it maps to this element. For instance, لو كان عندي vector اديني مثال مثلا اخذ مثلا 1 2 3. Okay, so the vector 1 2 3 it will be mapped to what? This is في الفيرست, دي في R3. How it will be mapped here to R2? How it looks like mapping T acting on this تديني شنو؟ تديني 1 and then adding this 2 plus 3 2 plus 3, which is 5 actually. So it will give me this one, this vector here. Is it clear now? Okay. Type. Now, the transformation of Cx, we have to prove that is equal to the transformation of x, and then we multiply it by c. So we start from this one. Okay, so this is equal transformation. What is the vector x? احنا قلنا what is the vector x from the beginning? The vector x اللي هو this one here, correct? Okay. يبقى when I multiply it, I'll do خلاص عارفين احنا how we multiply. So that is going to give me cx1, cy1, cz1 when I multiply this vector by the c, correct? Okay. So now we need what? T, a transformation of c x1, c y1, c z1. So how it is defined here? The first as it is, so it's going to be cx1. The second, we add this to this, correct? So it's going to be cy1 plus cz1. Okay. I'm putting in my mind where I want to reach. I want to reach here. That means I need the c out. Can I take the c from this vector out? Yes, because each element is multiplied by the c. So easily I can take it out. So this is equal to c في الvector x1 وhere y1 plus z1. طيب, and this is equal to what? What is this vector? This is طبعا c out. This is actually the transformation of the vector x1, y1, z1. Yes, as it is defined here. So this is equal, we started from this one and we ended that this is equal to c, a transformation of this vector which we gave it the big النيم شنو الفيكتور ده كنا مسمينه شنو مسمينه x, capital X. So equal to c transformation of x. So the two conditions are satisfied if the transformation is linear. Okay, actually this is what he did here. Let us see. He took arbitrary vectors. This is the first and this is the second. For every vectors x1, y1, z1 and x2, y2, z2 in R3 from the first, this one. Okay, and C a real number. Then we need the transformation of the addition. We need the transformation first of the addition. طيب, it is equal to what? We add first and then after we by the transformation. Okay, here they were added, and then now I should evaluate the transformation using this, the way he gave us. Type this, يبقى I will end up by this. Where I want to end. If the transformation is linear, I can separate them, this transformation alone and this alone, and then after that we add. طب can I do? Yes, I can take the various vector اللي هو x1, y1, z1 and the second vector, and then this is their addition. يبقى خلاص I separate them. Okay, is it the vector? Is it the transformation of this vector? Yes, correct. لأنه it is x, y, z, x, y, z. So this is يبقى the transformation of the vector x1, y1, z1, and this is the transformation of that. يبقى the transformation of the addition is equal to the transformation of the first, then adding to it a transformation of the second. يبقى we prove the first condition. And we did the same here in the case of the second condition. That is the transformation of what C في x is the same as C في transformation of x. So we proved it here as well. Any question for now, or it's clear? Is it clear? Any question? Now, show that the mapping from R3 to R3. How it is defined? It's defined like that. This is, yeah, it's element في R3. A resultant should be element from R3. Okay. And R3 is a vector space. So R3, الثاني is a vector space في شنو standard addition and scalar multiplication. We knew that. Okay, يبقى from a vector space to a vector space, another vector space, actually to R3 as well. Now, how it works? طيب, the first element is the addition of this two. Okay. The second element is the addition of this two. What is the last element? The last element is the same as this, but just add to it one. And now he asked me, is this transformation is linear transformation or no? It's very clear it is not. Why? Because with we said قلنا is the transformation linear في two conditions should be satisfied, correct? الأولاني فيهم a transformation of the zero vector should equal to the zero في other vector space here of zero في V. يعني if we have this is the V and this is the W, zero element should be mapped to what? To the zero element here, correct? Type here, how can I have a zero no matter? Okay, if I got x base 0, y 0, z 0, the result here is not 0 because 0 plus 1 is 1. So this is not happening. If it is not a vector space. Why? Because the transformation of 0, 0, 0, it is 0, 0, 1. It's not 0, 0, 0. It is not a linear transformation. As easily as that. If you want to try to prove the case there, اللي هو مثلا a transformation, is there another way for proving? Yes. اللي هو مثلا let's مثلا try to prove that transformation of CX. Okay, it should, if it is linear transformation, this is should equal to what? C في a transformation of what? Of the vector X. Correct? Type. Take this one. What's going to be? Transformation of CX. اللي هو you multiply. طبعا هتاخد x from where? From R3. Any اللي هو مثلا x, y, small, z. This is your vector. We call it x. Take x اللي هو from an element from R3. So it will look like that. Type. Now we want a transformation of CX. So we need the transformation of what? C multiplied times this vector. So it's going to be C, C, C. So it's going to be CX, CY, and CZ. Okay, what is this transformation? How it is defined? It is defined here. So this is going to be equal to cx plus cy. And then what about the second? The second plus the third. So we add this to this. So cy plus cz. Okay, what about the last one? It is the same at this one, then plus 1. So cz plus 1. Type. Is this one is equal to c of t of x? Definitely no. Why? Because c, a transformation of the vector x, actually it is c multiplied by what? By this one here, which is x plus y, y plus z, and then z plus 1. And when you multiply the c, this is going to be equal to what? cx plus cy, and this one cy plus cz. What about the last one? C, you multiplied here and you multiplied here. So cz plus c. يبقى هل هم equal؟ هل this one is equal to this one? Sorry, is equal to this one? Are they equal? Definitely no. Here plus 1 and here plus c. يبقى it's clear that your transformation is not linear. Yani we can prove that it is not linear. We try by 0. If it works, go and check the two rules. Or immediately, if you want to try first condition, the transformation of the addition هل is equal to transformation of the first plus the transformation of the second, أو هل this one, okay? يبقى if one of them works, you have to test the other, okay? You cannot immediately طوالي just say that. But if one of them does not work, خلاص, that's quite enough. يبقى it's not a linear transformation. And here, instead of we go like that, it's more easy. We test with the 0 first. خلاص, with the 0 from the beginning. If it is not satisfied, no need to check the others. خلاص, يبقى it's not a linear transformation. Clear? Clear? Right. Now, let T be a transformation from R2 to R2. Be a linear transformation, such that a transformation of this vector is 1, 2, and the transformation of this vector is 2, 3. Find this transformation. Now he don't want us to prove that it is a linear transformation. Already he gave us that it is a linear transformation. It is a linear transformation. That means what? The two conditions are satisfied. That is, the transformation of the first vector plus the second vector is the same as the transformation. Transformation of the addition is the same as the addition of the two transformation, tx plus ty. And as well, what do we have else? The transformation of c multiplied by x is the same as the transformation of x, and then after that we multiplied by the constant c. Okay? Okay. Now he told us that the transformation, he gave us how it works. The transformation of 1, 0, it's 1, 2. And the transformation of the vector 0, 1 is 2, 3. Type. He didn't give me the rule. I don't know. يعني before here كان بيوريني how the transformation is working. Okay. And then he asked, is it a linear or not? Now, no. He said that it is linear. And he gave me this transformation of this transformation of this vector, and as well the transformation of that vector. But I don't know what's the rule. And he wants me to find the transformation of this vector. From where? Just by the information I had before. I know that and I know that. But how can I find this? Type. Now, where we are? We are in R2. Okay, and R2 is a vector space under the addition, standard addition or the standard scalar multiplication. Yes, and we knew R2, we can span it or any vector x, y. It is vector where? From R2, correct? We can find it by by span our linear combination of what? Of the two vectors, 1 0, 0 1. Yes, we knew that actually these are bases. Yeah, I can construct using them the whole R2. Every vector here I can find it. For instance, if you want the vector, مثلا this one, 3 minus 2, what I do? 3, the first component 3. So I multiply here where there is a 1 by 3, 3 في 1 0. And then I need minus 2. If the other vector, I will multiply it by minus 2. 0 1, I will multiply it by minus 2. So, and then we do the addition. Correct? I'm going to get that one. So, yeah, we had previously that in R2, the vectors 1 0 0 1 are bases. That means what? They span R2. That means by doing a linear combination for these vectors, I can find any vector in R2. Okay? And they are actually even linearly independent. Linearly independent. Why? If we put them in a form of a determinant, لأنه هي طبعا عندي 2 row or 2 columns, so it's easy to use the determinant. So the determinant of 1 0 0 1, what is the determinant? This times that 1 في 1, كويس, minus 0, so it's equal 1. It's not equal to 0. يبقى they are linearly independent. يبقى yeah, they are bases for R2. خلاص يبقى if he gave us the transformation of the bases, I can find any transformation for R2. Why? Because any vector, I can construct it from these two. And also he told me that the transformation is linear. And this is important to find this transformation. I'll tell you why. طيب, we have what? We knew that the vector, what? This one, 3 minus 2. Okay. This is equal to what? This is equal to 3 times 1 0 minus 2 multiplied times the other vector, which I have been given their transformation, this one, okay, and this one. This is the most important thing. Type. Now, since the transformation is a linear transformation, that is the transformation of this is equal to the transformation of that. Correct? I need this. Type. If I can evaluate this one, I'm done. Type. But since the transformation is linear, then the transformation of the addition is equal to this alone plus this alone. This one, what transformation of the multiplication is the same as the transformation of by scalar is the same as transformation of the vector بعدين times the scalar, correct? طيب يبقى شنو؟ يبقى this one we can write it as this is equal transformation of 3 multiplied by 1 0, correct? بعدين plus a transformation of minus 2 multiplied by what? 0 1, correct? لأنه this is the case. لسه transformation of the addition, this is alone plus this is alone. يبقى we can do this transformation alone plus this transformation alone. And now we can take the constant out as well. Why? Because the transformation is linear, so we can apply this one. So this is equal to 3 في a transformation of the vector 1 0 minus 2 في transformation of the other vector which is 0 1. Okay, and this is equal to what? This we know it. Yes, it is what? It is 1 or 2. So 3 multiplied by the vector 1 2, and then minus 2 multiplied times what is the transformation of this 0 1? It is this one 2 3. So 2 3. And now just remains to do the calculations. So this is equal to 3 هنا 6 minus 2 في 2 ب 4 و 2 في 3 ب 6. Correct? So this is equal to minus 1 and 0. يبقى خلاص we finished. يبقى we need from the beginning transformation of 0 3 minus 2, and we got it. How we got it? From, since I know this, the transformation of these two vectors, and these two vectors are bases they are 2 خلاص يبقى I can use that لأنه transformation is linear. Okay, so I write 3 or minus 2 in terms of this, as here we did it. We found the constant اللي هم 3 و minus 2, correct? Linear combination, correct? هو 3 و minus 2, this C1 or C2. Okay, and now since my transformation is linear, then the transformation, this is going to be the addition or multiplied by the constant, whatever, is equal to what? Transformation اللي هو the addition or multiplied by constant. So it is going to be equal the, I'll tell you one thing. This is just like احنا مش قلنا a transformation of C, let's say C1 X plus C2Y أو R X و S في Y whatever المشكلة النيمينج صح. This is equal to C1 a transformation of X plus C2 transformation of Y, correct? Yes. So this is actually what we applied here. Okay. يبقى this one, it is a transformation of this plus the transformation of that. And then this is a multiplication, a transformation of Cx. So we take the 3 out, 3 transformation of 1. Okay. So it's clear. Is it clear? لحد ما وصلنا to the solution at the end. طيب. If he gave me other vectors and he said that they span R2, okay, they span R2 and they are linearly independent, immediately معناها they are bases. If any other vector you can find it in terms of them. أي vector تاني برضو ممكن أجيبه in terms of them. واضح؟ يعني ما بالضرورة these are bases, but they are two, they are other bases. ممكن يكون في any two vectors that are linearly independent. صح؟ They are bases. This is we did it in our previous class. يبقى لو اداني two linearly independent vectors يبقى they span R2 و immediately I'll do the transformation. واضح؟ يعني مثلا لو كان عندنا ادانا if he gave us مثلا the vector 1 1 and he gave me its transformation, and then he gave me the vector 1 0 and he gave me its transformation. Can I find this transformation or no? احنا عرفنا في R2 any two vectors, so this one and this two, the second, if they are linearly independent, they will span the space. They are bases. طيب يبقى remain شنو؟ Are they linearly independent ولا لا؟ هيكون 1 1 1 0. I can find the determinant. أسهل مما أجيب C1 و C2. صح؟ 1 في 0 ب 0. 0 minus 1. So the answer minus 1. يبقى لا تساوي 0. يبقى they are independent. يبقى yes, I can find any vector in terms of them. How can I find the vector in terms of them? Tell me. يبقى احنا عايزين اللينير كومبينيشن، صح؟ عشان نجيب الفيكتور 3 وماينس 2. متذكرين how we get the C1 وال C2 to know. هعمل شنو؟ هعمل 1 1 1 0 and this is 3 وماينس 2 and I am looking for what? C1 and C2. Yes? Is 3 or minus 2 a linear combination of this and this? Should be. Why? Because they are bases. They are R2. So any vector في R2 I can find it in terms of them. In particular 3 or minus 2. طيب يبقى we are looking for C1 C2. Go and solve and find C1 and find C2. And then after that خلاص you know what you will put here for C1, what you will put here for C2. وبدل ما كانوا الفيكتورز حقتنا 1 و 0, the first one is 1 1, so this is going to be 1 1, and the second time مثلا for instance 1 و 0, okay, but different C1 طبعا و C2. Okay, clear? Any question for now or it's clear? طيب, let A be this matrix and define the mapping T from R2 ل R2. Okay. By T of X is equal to A of X. How this map is this is a matrix, and now our transformation, it's from R2 to R2. How? We take a vector from R2, we multiply it by the matrix A, or A actually times the vector, so will give us the vector here. Type for every X belong to, shows that T is a linear transformation first, and then after that find the transformation of this vector, which is here. Type. We said that to prove that the transformation is linear, we have to prove two things. The first one is that a transformation of X plus Y should equal the transformation of X plus the transformation of Y. Okay, first what we do, we're في R2. Okay, do I need بالذات لما يكون في matrices يعني no need to do multiplication and put x1 y1 خلاص we know that this is our x. What is our y? Another vector, so x2 مثلا y2. Okay, so this is our y. Okay, so the transformation of x plus y, how it works, it is what, now this is the vector هيكون x plus y, so it's going to be equal to what? A multiplied by xy. If the transformation of x plus y is the same as A multiplied by the vectors x plus y. Okay, طيب, before what we said, if this is a vector and this is a vector, we had a rule. This is a matrix, so this is the same as A في vector x plus A في vector y. If you don't like to write it like that, you want like this, okay, A multiplied by this plus that is the same as A في x1 y1 plus A في x2 y2. Okay, so no need anyway to write it like that. It's خلاص easy, it's clear from here. If you want, you can do. Okay, so this is equal to this one plus that one. But what is this? This is the transformation of x. And what is this? يبقى حيكون transformation of y, and here the addition, transformation of y. يبقى we prove the first condition. A transformation of the addition is equal the transformation addition of each of the two transformations. Correct? So we prove this one. Remain the second one. The second one, what do we want to prove? We want to prove a transformation of the vector cx is equal to what? Type a transformation, how it works? We take the vector, we multiply it from the left hand side by the matrix A. So this is equal to A multiplied by the vector cx. طيب, and this we had before theorems. لما يكون عندي matrices of vectors, this is a constant, we can take it out, correct? So this is equal to c في a times the matrix x times the vector x. But what is this? This is the transformation of x. So multiplied by c. يبقى we found that the second condition as well, we proved it. Transformation of cx is equal to c transformation of x. يبقى we are done. يبقى this transformation defined like that is a linear transformation. يعني okay. Then he asked me to find the transformation of 104. Okay, how it works, a transformation? Just you multiply from the left hand side by this matrix. So it's going to be equal to 1, 2, 3, 0 multiplied by the vector 1, 4. This is the transformation of the vector 1, 4 as per the definition. على حسب الديفينيشن المحتى. A transformation of 1, 4 is equal to a matrix times x. Matrix times x. So you do the calculation and find it. So it is 9, 3. That means the vector 1, 4, yeah, is mapped to the vector 2, 9, or 3. Any other vector في R2, you can find it by multiplying A times that vector as per the definition. This is how and we prove that this kind of transformation is a linear transformation. Clear? Type, determine whether transformation from R2 to R defined by this is equal to that is a linear transformation. هل هو linear transformation or no? First, the most easiest thing, I start with checking the zero. هل a transformation of a zero vector is equal a zero or no? Type. So this is 0, this is 0. How it is defined? 0 plus 0, which is equal to the 0. يبقى هنا في R square كانت 0 0. Yeah, it is mapped here في R 0 1 صح؟ Okay. يبقى هل that means it is linear transformation? No. It could be linear or not. واضح؟ But if this is not satisfied, then immediately بقول شنو? It is not a linear transformation. If now this doesn't help, what we do? We go and check the other two conditions. Okay, so what? Always start with the multiplication because it's more easier. Type transformation we need of cx. Is it equal to c transformation of x or no? Type. How the transformation is defined? It is the first square plus the second square. طيب يبقى we need the transformation of cx, that is the transformation of c multiplied times the vector xy. How we multiply c? So it's going to appear here and here. Now we need the transformation of this vector. Type the transformation of this vector is equal to what? How it will work? The first square, what is my first? It is cx. So the whole cx square. Plus, what about the second? cy, the whole square. Type this is equal to what? This is equal to c square x square plus c square y square. طيب أنا جبت transformation of cx. Is it equal to c في transformation of x? This one, it is equal to c square في x square plus y square. That is equal to c square. What is this? It is a transformation of xy. So equal to c square في transformation of x. طيب, that means it is wrong. The other condition, it's not satisfied. So the transformation is not linear. Why? Because this is c square, while here I should end up by c, or not c square, correct? So IBGA, the transformation is not linear. As a homework, go and test t of x plus y. Is it equal to the transformation of x plus the transformation of y or no? If one condition, خلاص, for one condition, it is not satisfied, خلاص, immediately it is not a linear transformation. Now I want you to prove it that it is not linear transformation by checking this one. Okay? Question. Let's assume this works. Let's assume this works. هل immediately هقول it's linear transformation? No. I have to go and check بعد the other one as well. If all they are satisfied, then it is a linear transformation. Okay? And if one condition is not satisfied, this or حتى zero, then immediately I'll say that it is not a linear transformation. Clear? طيب, define the linear transformation T from R2 to R2 by how it works, how it is defined. What we do? We switch or flip with minus sign. Okay. Find a 2 by 2 matrix A such that the transformation of X is equal to A في X for every X in R2. Okay. He told me that this transformation is linear, so no need to prove it or أي حاجة. Okay. It's already linear. He told me that it's linear. I need a matrix 2 by 2 that it will work the same like that. طيب, I can start assuming that the matrix A هي الماتريكس الالمنتس حقنا A B C D. Okay. And this matrix, okay, we need it to work the same as this one. That is, when you multiply times any vector, x, y, the resultant, because we need it the same as this. So when I multiply A times X is the same as transforming of X. Then what is the transformation of X? It is this one. So we need the answer to be equal to what? Minus Y and here minus X. So what we do? We multiply. So what we'll get? The first element. It is AX plus BY. What is the second? Correct? This is 2 by 2. And this is 2 by 1. So what is the resultant? 2 by 1, correct? Type IBGA, we multiply this one by xy, so I get ax plus by. What is the second? What is the second element? How you get? We multiply this row by the column, correct? So it's going to be cx plus dy. Correct? So this should equal to minus y and here minus x. Yes? Type. That is, this one should equal to 0 because this is a term فيه y. Correct? يبقى A should equal to 0 and B should equal to minus 1. And from the second, equality of the second, that means what? D should equal to 0 and what? C is equal to -1. خلاص يبقى I knew the matrix. What is the matrix? A, B, C, D. What is the A? A is 0. What is the B? -1. What is the C? -1. What is the D? 0. So it is this matrix. Clear? Or else another way, and it's more easier في calculations. طيب احنا في R2 the vectors 1 and 0 0 1 are bases. Any vector I can find it في R2 in terms of them. Not that only, but also it's easier for calculation. If the matrix A works the same as the transformation that is defined here, then it should work for 1 and 0 and for 0 1 as well. This one and this one. طيب يبقى what is the transformation of 1 and 0? What is the transformation of 1 and 0? y 0 يبقى this is 0. Here going to be -1, correct? So we evaluate this one. And my matrix should work the same with this vector 1 and 0. So this time that it is A or C. يبقى now I compare. Now I compare. Okay, what we compare? This one should equal to that one, correct? لأنه المفروض يكون شنو؟ A في الماتريكس في الفيكتور 1 و 0 it's the same as the transformation of the vector 1 و 0. طيب I got the transformation of 1 و 0 from using شنو؟ Using the rule here. So I got what? I got this. And now I multiply this time that. I got what? I got this. Now I compare this with this. What is the A? It is 0. What is the C? It is -1. So that means في الماتريكس حقتي اللي هي A, B, C, D already I found what the value حقت ال A was C. This is I knew that it is 0 وحقت ال C it is -1. I knew that this is -1. Now we do for the vector 0, 1. The same we do for the vector A multiplied by the vector 0, 1 should equal a transformation of 0, 1. So we do it, we can find if you multiply this time that A في 0 0 plus B في 1 B. And then this for this BD. And now you compare this with this one. So you can get the values of the other two اللي هو ال B with D. And you're done. يبقى that is the matrix. Okay? Or you can solve like that. Okay? طيب, if you want to make sure that this is correct, take this one and multiply it by any vector and see is it going to work like that or no. يعني for instance 0 or -1 or -1 0 multiplied في vector 2 3 for instance. So what is the resultant? 0 في 2 ب 0 -1 في 3 is equal to -3. طيب -1 في 2 is -2 plus 0 في 3 0. So this is -2. Isn't it the same? Flipped and with minus sign? Yes. And this will work the same for each and every vector in R2. Okay. So yes, this matrix will work the same as this transformation. Clear? Clear? طيب إن شاء الله within 15 minutes we can finish. طيب now any question? We knew what is a linear transformation, what conditions, what are the two conditions, how things work. Type. Now, we want to define the null space and the range. What is that? Type. We knew what is a transformation. If we have a linear transformation, okay, from vector space to another vector space, okay, مثلا from V to W. Okay, it takes elements to elements. مثلا this is X. Okay, it takes t of x مثلا تساوي y etc. correct? Like that t. Now n of t is what we want. Which elements in this vector space, part of this vector space, they will map with what? With the vector 0, not any y. So this one should map to the 0 vector, and this is another x2 also should be mapped to the 0 وهكذا. So we need this set. This is, we call it nullity or n of t, our null space. A null space n of t. So what is nt? Nt is this set of elements from the vector space V that will be mapped to the 0. That is, every element here in that part, t of x1 should equal to 0. T of x2 should equal to 0. So we need all these x's that will be mapped to the 0 by this linear transformation. Okay, so that set we call it null space, or a null of the T. Okay, يبقى by definition, what is that set? It is, the set is the set of vectors from where? From V. The set of vectors, let's call them X. X from where? From V. Okay, but any X? No, they should satisfy certain condition. What is that condition? Transformation of these vectors, each of these vectors should equal to what? Should equal to 0. والزيرو وين؟ 0 here في W طبعا. عشان كده بنكتبها 0 W. Is it clear what is the null space? Null space هو عبارة عن elements when part, or it could be كل الvector space V. Anyway, they are elements from the vector space V such that their map, or they will be mapped by this linear transformation only to the element 0. So these elements, we call them null space. Clear? طيب. Now we want to define another thing. What is it? هو a range of the linear transformation. طيب, what is the range of the linear transformation? طيب, if this is the V and this is your W, okay, we need خلاص these كل elements here in this, all of them, they will be mapped to what? To all W or to some elements here. It could be for all W or part. Anyway, we need, they exactly will be mapped to what? What is their range? What is their image set? Okay, so if في range R of T, that means we need the elements here. N of T, we need the elements here that are mapped to the 0. What are they? What are these elements that their map is 0? في R of T, we need the elements في W that every element here, if I take it, its map will be there. Anyone not out of here. So what is that set? Okay, يبقى what is R of T? R of T هو عبارة عن شنو؟ T of all the x's such that from where I'll pick T of x معناه هو قاعد في W. طيب, from where I'll pick the x, I'll pick the x from here. So T of x such that x is an element when في V. Okay? Is it clear what is the N of T? What is R of T? What is the null space? What is the range? Any question? طيب, define the linear transformation T from R3 to R2 by how it is أول حاجة he gave me that it is linear transformation. It is mapped from R3 to R2. This is yes الفيكتور الأول كان في R3 and when we act with it with T the answer or the resultant it is in R2. Okay. He wants me to find the null space n of t. طيب what is n of t? قلنا n of t we are looking after what elements here في the first vector space which is R3 that their map is what the zero vector here. That means what? That means we need this vector to be the zero vector to find the elements here. Okay. يبقى هيكون عندنا شنو؟ We let that this part is equal to 0. When? 0 where? R2 اللي هو 0 0. طيب يبقى بقى عندنا شنو؟ Linear equation, system of linear equation. What's the first equation? X minus Z is equal to 0. What is the second equation? Y plus Z is equal to 0. Isn't it system of linear equation? Yeah, it is system of linear equation. Solve to find what? To find the values حقتنا حقت الX والY والZ. Like we have been doing before. What we do first, find the augmented matrix. What is the augmented matrix? It is 1 0 minus 1, correct? And here 0 and then 0 y coefficient حقها 1 z coefficient 1 and then here 0. Solve the linear system, reduce to the echelon form. Fortunate enough, in this example, already it is in the echelon form. Already, this is the first leading one, correct? Under it is 0. Here, this is the leading one, and here 0. خلاص يبقى how many solutions we have? We have solution or no? Yeah, we have, correct? How many? Infinitely many number of solutions, correct? Because the number of leading one and the two leading ones. Well, unknown 1 2 3 columns. يبقى what? How is the solution? Which column that has no leading one? This one, who corresponding to Z. Let Z is equal to T, correct? Then we come here. X minus T بتساوي 0. يبقى minus T is equal to 0. That is X بتساوي T. And then from the second, 0 of X by 0 plus 1 في Y. Y plus T is equal to 0. That is Y is equal to minus T. And lastly, Z بتساوي T. يبقى we get the solution. يبقى which vectors? احنا we're looking for the vectors from here that will map with the 0. How they will look like? They will look like this. So they are the vector T or minus T or T, okay, like that, such that T is any real number. So all the set of all these vectors will be mapped to the 0. If you want to check, take a T بتساوي 2. 2 minus 2 و2. طيب هل this vector will be mapped to a 0 or no? Apply this one. What we do? The first ناقص the third. The first minus the third. Here 2 minus 2, correct? This is the third and this is the first. It is 0. And then what about the second element? The second plus the third. Minus 2 plus 2. Yeah, it is also 0. So yes. And every element in this form, it will be mapped to the 0. يبقى what is the null space? It is the set of these kind of vectors. Clear? Clear? واضح? It's really easy. عايزين a null space just here. This part equated with 0 and solve. So the set of vectors اللي هيطلع لنا, these are the vectors are that will map to the 0 vector. Clear? Now, what we need? We need the range. طيب, how we find the range? How we find the range? طيب, احنا قلنا what is R of t? What is R of t? طيب, if this is the vector v and this is the vector space w, we need all the elements that are here are mapped where? What is their images? What is the set of the images of this vector? So it could be part and it could be all w. So if it is part or all w, anyway, we need them. هل هو all w or part of it? If part, which set? Correct? Type, that means what? I need the transformation for every vector x here. So I need the transformation of x, y, z, because my transformation was defined from R3 to R2. So I need every, and I took arbitrary vector x, y, z. So I need every vector like that. It will be mapped to what? I get it and put it where? In your set of R of t. عشان ما أجيب R of t. عشان to get this set. طيب, هل هاخد infinitely many number of vectors? I find the طبعا ممكن يكون الانسر infinitely many. طب هل هو كله W؟ كل ال R2؟ How can I know? Just like that. What? Since I am in R3, I know that R3 can be spanned by the vectors what? 1, 0, 0. أول حاجة R3 عنده كم bases؟ 3. احنا قلنا Rn theorem we had it عنده n شنو؟ bases. In particular R3 عنده 3. Any 3 linearly independent, they are vectors, are bases of R3. Any 3 linearly independent vectors from R3 are bases to R3. In particular 1, 0, 0, 0, 1, 0, and the vector 0, 0, 1. If these vectors can span the space of R3, what's the meaning of span? I can get any vector in R3 by doing linear combination for this vector. Or any vector there, it's a linear combination of these 3. Correct? طيب. يعني مثلا x1 y1 z1 هو عبارة عن c عن x في this vector, y في this vector, and z in this vector. Okay, so what? Any vector like that is عبارة عن شنو? How we got it? By span linear transformation, correct? Span يعني linear transformation, correct? Of what? Of the vectors, of the 3 vectors, 1, 0, 0, okay? And 0, 1, 0, and 0, 0, 1. So by doing linear combination for this vector, I can get this one. That is span this is equal. I can get this one. Then after that, I can find the transformation of this. طيب, السبان is what? احنا قلنا linear combination. يعني شنو؟ يعني C1 في 1, 0, 0 plus C2 times 0, 1, 0 plus C3 times 0, 0, 1. Correct? عشان ما يديني الفيكتور شنو؟ C1, C2, C3. لو خطيت هنا 2 هنا 5 وهنا minus 7. So this is going to give me the vector 2, 5, minus 7, for instance, correct? Like that. طيب, now, if I need the transformation of this, so that is equal to the transformation of that. And since the transformation is linear, then what? So this one equal to C1 transformation of 1, 0, 0 plus C2 لأنه transformation is linear مش عشان أي حاجة 0, 1, 0 plus C3 في a transformation of 0, 0, 1. But what is that? Tell me, what is this? This is again a linear combination, a linear combination C1, C2, C3. وهنا عندي addition of what? Of the new vectors, of this vectors. Correct? So this is a linear combination that is span of what? Span of T100 و T010 و T001. Why we do that? Because the transformation is linear. So I can, as if I'm taking it like that. Okay, and now take it as a rule. If he told you that the transformation is linear and he want the range, okay, على حسب السبيس R3, so the range is equal to what? To span a transformation of 100, transformation of 010, transformation, or the linear combination of the resultants of these transformations. Clear? يبقى from now on إذا سألني من الرينج هعين السبيس 3. So I look after لأنه every vector from this can be written in terms of this 3. لو كان R2 every XY can be written in terms of 1 0 0 1. R4 هيكون في 4 vectors 1 0 0 0 0 1 0 0 وهكذا all the 4. اوكي يبقى R of T هيساوي شنو؟ R of T that is بدل ما اكتب انه بساوي I need what I need كل transformation of the vectors, but this okay I can write it as what? As a transformation here. I can write it like that. Transformation of الفيكتور ده هو ده. طيب, but since the transformation is linear, I can take this out and put this in. في كل vector here. So this is equal to the span of what? Of a transformation of the vector 1 0 0 what? Transformation of the vector 0 1 0 what? A transformation of the last one like that. So خلاص. From now on you do like that whenever you want the range. Clear? بس take care. أنا في R3 يبقى لازم هنا 3 vectors. في R2 لازم 2 vectors only 1 0 0 1. R4 4 وهكذا. Clear? طيب, what is transformation of 1 0 0? You come and apply the rule here. X by 1 was Z by 0, Y by 0 was Z by 0. 1 minus 0, it is 1. 0 plus 0, it is 0. And you do the same. Now this vector, the second vector. So X by 0, correct? Z by 0. And then Y by 1 and Z by 0. So 0 minus 0, it is 0. 1 plus 0, it is 1. And you do the same to find this one. يبقى what is the range? R of T is what? R of T is the span of these 3 vectors. But we are where? We are in R2. Any 2 linearly independent, they are bases enough to generate R2. We need, 2 linearly independent vectors. I don't need 3. لأنه لو كانوا 3 definitely one of them depend on the other 2. خلاص لأنه اداني قاعدة قال لي في R2 any 2 linearly independent they are the basis. طيب أنا هنا طلع لي span وباي 3 vectors. 2 of them are linearly independent. خلاص. Okay. So I can generate كل ال R2 by this 2. So this space is the same as this space. لأنه this is bases they are enough to generate كل ال R2. يبقى ده ما حيديني حاجة جديدة. Also I'll get the same R2 with them. طيب but this one what is the meaning of this؟ السبان يعني شنو؟ يعني linear combination of these two vectors. So it is like that. If you want to write it, write it. If you don't like or want, خلاص, no need. So what is this? What space is this? It is the whole R2. يبقى what is the range? It is R2. That means what؟ الفيكتورز حقينك اللي هم شنو؟ الفي في will be mapped اللي هم V كان شنو؟ R3 correct؟ R3 and this is R2. So these vectors will be mapped to شنو part here? No, to all R2. We need all R2. كل ال R2 هو images. Every element here في R2 it's an image for an element here as per this transformation. يبقى the range is R2. Clear? Clear? We do the last example وخلاص we finish the chapter. طيب, let's do that. At the beginning you will, as if it is difficult, but now you will see that it's really easy. طيب, now let T from R3 to R3. That is, احنا from R3 we are mapping to R3. What we need to R3? What we need? It is linear transformation. We need N of T and we want R of T. طيب, N of T, that means we need the elements here that will map to 0. احنا عايزين بس this one to be 0. That means we need this one to be 0. So what we do? We equate this one with 0, 0, 0. Okay? Element. المابينج في R3, this one should be شنو? 0, 0, 0. And now system of linear equation reduced to the echelon form. خدتها في augmented matrix reduced to the echelon form. What is the augmented matrix? هنا عندنا x, so 1, والy 0, والz 0. And this هنا 0. هنا x 1, y 1, z ما في 0. Here 0. The last x 1, y 1, z 1. And here 0. You can reduce to the echelon form and solve. But easily I can solve from here. Why? Because this is lower triangular. Correct? I start from this. هنا ده x, ده y, ده z. X is equal to what? 1 في x plus 0 في y plus 0 في z. يبقى x is equal to 0. Now we come here. What do we have? We have 1 في x, x plus 1 في y by y is equal to 0. But already I got the x by 0. يبقى what about the y? Y is 0, correct? Then 0 plus y is equal to 0. يبقى شنو؟ يبقى ال y is equal to 0. So we got the y value. And from the last, x plus y plus z is equal to 0. But the x by 0 wal y by 0. يبقى the z as well is 0. That is z is equal to 0. يبقى which vectors here are mapped to the 0? هم ال vectors x, y, z ياتوا اللي هم بيساووا 0, 0, 0. يبقى there is only one vector في R3 will be mapped to the 0, 0. يبقى ال n of t هو only the vector شنو؟ 0, 0, 0. الست فيه only one vector هو this set اللي هو فيه only one vector. يبقى only one element here will be mapped to the 0. Only one element اللي هو شنو؟ 0 vector بس هو اللي will be mapped to the 0 على حسب السوليوشن حقنا. هل زي الفات جبنا infinitely many number of solutions مثلا؟ So for every x, y, z ولا whatever? No. هل في certain ones? No. If بس only في 31 only one correct اللي هو zero vector here. So the zero vector لقيناه it will be mapped to this one. Okay, clear? And if you want to test عوض 0 0 0 0 هنا ده 0 0 plus 0 0 0 plus 0. Yeah, so this is any other thing. If you put any other numbers, you will not find that the result is 0 0 0. Clear? يبقى we found the nullity, the n of t. Now remain to find what r of t. Type when I'm looking for r of t, what I'm looking at, we need this element where في r3. هل they mapped here? We need all three or part from r3, correct? We are looking these elements. They are part from r3 ولا كل ال r3? We need the image set. Okay, we need the image set. Every element here should be mapped. Okay, we said what? We said when we need r of t, always r of t is equal to what? Is equal the span of what? And احنا وين؟ في R3. So I need 3 linearly independent vectors in particular. In particular 1 0 0 0 1 0 صح؟ يبقى T ده ما تنسى T of 1 0 0 و T of 0 1 0 و T of 0 0 1 because my transformation is linear. Okay, actually every element x y z في R3 I can get it in terms of these vectors by doing linear combination. But since the transformation is linear, I can take the t inside. يعني بدل ما find the transformation of the linear combination, we find the linear combination of the transformations. لأنه the transformation is linear. And now we find this one, t of 1 0 0. What is t of 1 0 0? What is t of 1 0 0? It is the vector 1 1 1. How you got it? Just substitute here. Here, al x1, al y0 was z0. So clear 1 1 1. And now you do the same for this one. You get that. This you do here and you get this. So it's the span of this. Okay. Linear combination of these 3 vectors. Are they bases or no? Are they bases or no? أنا في R3 I need what? 3 linearly independent vectors. لو طلعوا that means كل ال R3. معناه any vector في R3 here I can get it. Correct? طيب هل or no? It's clear to know that they are linearly independent ولا لا. Either to find C1 و C2 و C3 but more easier قلنا في حالة إنه عندي 3 rows و 3 columns I can use the determinant to evaluate that. حيكون عندنا 1 0 0 1 1 0 1 1 1. Okay, what is the determinant? Because triangular, we multiply this. This is equal to 1, not equal to 0. Yes, that means the 3 vectors are linearly independent. Correct? يبقى they span, they generate كل ال R3 here. يبقى that means every element here is an image في R3, not only part. يبقى the whole R3. Clear? The whole R3. واضح؟ طيب لو كانوا مثلا يعني لو كانت 3 not linearly independent كان هعمل شنو؟ كان هاخد الديبندنت. يعني لو كان only these two and this depend on them كان هشيله برا وهكتب span of this. And now هل span of this هيديني كل ال R3؟ No. 2 vectors only they cannot generate كل ال R3. احنا عشان ال R3 لازم يكونوا 3 linearly independent vector. كان هيكون الانسر شنو؟ just span of these 2 vectors وخلاص ما هكتب. You got it? Clear? Clear? واضح؟ طيب the last thing, let T be a linear transformation from Rn to Rm. Okay. A null space n of T is a subspace. Now, if he told you to find n of T, immediately it is not a subset. It is a subspace. The elements here that map to the zero, this part is what they are in vector space. Rn is a vector space. So this one is what is a subspace of Rn. Clear? Moreover, if we have this is Rn and this is Rm, and we have a map linear transformation from Rn to Rm. Type if this is mapped المap set of this by applying T لكل الاليمنتس في Rn, and you got that one, you got this part. So this part again, it's a subspace from where, not only subset, from where, from Rm. يعني all the 10 conditions بتاع الاديشن وال standard addition وال standard scalar multiplication are satisfied where here. Clear? So it is a subspace as well. Moreover, the dimension of NT with dimension of RT is equal to N. What is the dimension? The dimension of a space is the number of bases, correct? Let's go to the previous examples. Type here in this example, T from R3 to R2, N with 3. Type. Now, N of T طلع شنو؟ طلع this one. طيب, this one actually it is what this is اللي هو عبارة عن T multiplied by the vector 1 or minus 1 1. Correct? T في this vector. So that means what? I have how many bases? Only one. Correct? So this is like a constant multiplied by this. Okay? So that means n of t تساوي 1. الدايمنشن حقها او yes is equal to 1. طيب what about r of t? طيب لو جبنا ال r of t وين المسألة؟ n of t yeah. طيب what about ال r of t? ال r of t طلع كم؟ 1 2. البيزس صح؟ طلعوا 2. I constructed this part by 2 vector. Actually اداني كل ال R2. يبقى الdimension is 2. So 2 plus 1 it is the 3. طيب again. Here there is another example. Here it is 3. Correct? طيب. الdimension بتاع R بتاع n of t بكم؟ What is the null? n of t جبناه بكم؟ n of t only the zero vector. وإحنا we had like a theorem. A dimension of this is 0. Okay? A zero vector. السبيس الفيكتور سبيس اللي فيه only the zero vector. A dimension of it we say that it is 0. طيب okay. Now R of t. What is the dimension? What are the bases for this? We came here, we find that this, they are linearly independent. So that means we have 1, 2, 3. Correct? يبقى for this part اللي هو حق R of t, the dimension is 3. So 3 plus 0, it is what? It is the n. It is 3. هنا 3. 3 plus 0, it is equal to 3. Yes, is equal to this n. Okay. يبقى the dimension of n of t plus the dimension. What is the dimension? A dimension is the number of bases. A number of bases. Don't forget. Type. That means this one. To find this one, we need how many bases? Plus, to find this one, we can find it in terms of what? How many bases? Add this to this number of bases. Okay, it will give you this n here. It should be the same like that one. Okay, clear? طيب, now moreover, let A be m times n matrix. A rank of A is the number of leading ones in the reduced row echelon form of A. طيب, أي matrix when you put it أن تصل للreduced echelon form، لو كان عندنا هنا 1 0 0 مثلا and here 0 1 0 and this is 0, this is 2, this is 3 for instance. This is for reduced echelon form. Yes. طيب, what is the rank of the matrix? The rank of the matrix is the number of the leading ones. And become leading one. This, the leading one for this. This, the leading one, correct? Here has leading, no, has no leading one, correct? Ibga, I have how many leading one? 1, 2. Ibga, what is the rank of this matrix? It is 2. Ibga, rank of matrix A of A is equal to 2, اللي هو number of leading ones in the reduced echelon form. Okay. Moreover, what is the nullity of A? The nullity of A is the number of columns that has no leading one. How many columns has no leading one? هنا ديل لقيناهم اللي فيهم leading one 2. 2 دي شنو؟ the rank of A. طيب اللي ما فيهم leading one 1 vector. That we call it, in this example طبعا, that we call it a nullity. Okay? So the nullity of the matrix is what? Is the number of columns that has no leading one. اللي هو it is only 1 here. Now, the rank of A plus the nullity of A. So rank of A 2, nullity of A 1, 2 plus 3 plus 1 3 should equal to what? A matrix M for the number of rows, N for the number of columns. طيب the number of columns لو كانت هنا N. الماتريكس دي is كم؟ مثلا for instance in our example 3 by 3. يبقى أكيد a number of the columns اللي فيهم leading one plus that they don't have leading one هيديني كل number of columns, correct? يبقى the rank of A plus the nullity of A should equal to N. Correct? واضح؟ Here, this is 1, 2. يبقى the rank of A is 2. طيب but a nullity كم؟ What is the nullity? How many? How many columns has no leading one? Is 1. So 2 plus 1 is equal to 3. Correct? اللي هو بتساوي شنو؟ الماتريكس شنو؟ number of columns اللي هو equal to a number of columns. اللي هي ال n دي عبارة عن number of columns. اوكي. طيب الماتريكس متى تكون non singular؟ non singular معناه شنو؟ معناه has inverse. When the matrix will has an inverse؟ طبعا عندنا determinant ما بتساوي 0 or to has an inverse to have an inverse. This is if it's like that, when you reduce to the echelon form, this part should reduce to I, and then in that case this is the inverse exists and this part is the inverse, correct? Okay. طيب, that means when reducing to the echelon form, this matrix, when we reduce it to the echelon form, how it will look like? هتبقى شكلها زي identity, correct? One في diagonal, while others here are zeros, correct? So it is the identity. يبقى في الحالة دي number of leading one شنو؟ every column will has a leading one, correct? Every column will has a leading one. يبقى هل في column ما فيه leading one? No. يبقى nullity حتكون بكم؟ nullity is going to be equal to 0. والrank حيكون هو عبارة عن a number of columns. الrank is the number of columns, correct? The rank is the number of columns. كل الcolumns صح؟ ده محل when is that? When it is non-singular. That means has an inverse. لأنها it will reach to the شنو؟ echelon form. How it looks like when we reach to the echelon form? It looks like the identity, which is that. That means each column should has a leading one. The rank of A هو عبارة عن a number of columns. والnullity هل في any has no leading one? No. So the nullity is 0. Okay, we finished this chapter. If you have any question, you may ask. Okay.